So, NVIDIA RTX 4090. When I released the unboxing video, then a lot of people commented about the power consumption and how this is just going downhill. We have bigger graphics cards, more power consumption. This is just insane, right? But people can't be more wrong than that. Wait till you see the benchmarks results. Because in this video, we're going to be comparing this RTX 4090 to the RTX 3090 and seeing if the RTX 4090 is worth buying over the RTX 3090. But you know what is worth it? This sponsored segment.
Looking for a cheap way to license your Windows? Check out WhoKeys through the links in the video description. Make sure to use the code TN20 to get a 30% off. Paste the license to the activation settings and you're all done. This license is for Windows 10, but you can upgrade it to Windows 11 for free. They also offer Microsoft Office 19 license. Use the same code TN20 to get a 30% off. Check out WhoKeys.com in the video description below.
So with the 40 series graphics cards and the RTX 4090, there's a few other features apart from just performance, kind of raw performance that was changed. First of all, DLSS 3, which mostly relates to gamers, like you get basically more frames per second in higher resolution. So it's like an AI upscaling in your gaming performance. But also it's very interesting for creators because, for example, if you're a 3D creator and you're sick of creating in your viewport and you have to downscale your actual project just because your PC can't actually render out those big scenes and you can't see the final product, then now with the DLSS 3 and with the software optimization, you can actually see the final product in real time, which is very, very good for creators. Obviously, software optimization is needed there. But basically, 3D artists can create 4K 60 frames per second with the help of DLSS 3, the new generation of RT cores, which are ray tracing cores, and shader execution reordering, which basically is just reordering what you're calculating so it's more efficient to give you the actual final result. Second big thing is the encoders of the actual graphics card. So previously we had one decoder and one encoder, but now we have one decoder and two encoders. And the RTX 40 series support AV1 encoding, which is absolutely fantastic. If you don't know what AV1 is, it's basically more efficient video code than H.264, H.265. It basically means it gives you better picture quality for the same file size. For example, AV1 is 40% more efficient than H.264. I was really excited about the encoders because I thought this is going to really change the game for video editors, but there are a few things you need to know which can be a bit confusing, with the NVIDIA marketing. Basically, the decoders are exactly the same as last year. So if you expect to decode H.265 422 10-bit footage, then this is not accelerated on the 40 series graphics cards like it wasn't on the 30 series graphics cards. But if you do want to encode H.265 or AV1, then that is now supported on the 40 series and is much faster because there's two encoders. Basically what this graphics card can do smartly is split your frame in half, and then one encoder encodes the top part and the other one the bottom part, and then later on they'll put the frames together, which can accelerate your encoding up to 2 times. Now bear in mind, it's very important that you do have the right codecs. It only supports the encoding for AV1 and H.265. If you're exporting into some kind of other format, then it's not going to be supported on these encoders. That really reflects to H.265 and AV1. And also we're waiting for the video editors to actually publicly release these builds where this is supported. Now DaVinci Resolve already has a pre-released like a beta version that supports built-in AV1 encoding and AV1 basically. But for Premiere Pro, you have to use vocoder to actually encode that footage, which is a right pain, and I am not a big fan of that vocoder at all because first of all, it makes your Premiere Pro super slow. I wish AV1 was supported in Premiere Pro, so we're gonna have to wait for that, waiting for Adobe to respond. But also a huge thing, what this AV1 encoding actually supports and why it is so good is that when you're live streaming, for example, if you buy a PC and you want to live stream, whether this is your gameplay or just like actual footage, like you're recording, let's say like I'm doing here, sometimes live PC builds with these cameras, you've got something that captures it and then you're gonna live stream it to YouTube Now you can do it with AV1, which means you can decrease the file size you're sending to YouTube or whichever streaming platform you're going to send it to. Your internet speed is not going to be the bottleneck of your video quality. You can send much better video quality there with the same internet speed that you have basically, which is just absolutely fantastic. And ray tracing, this is the best ray tracing card right now in the world. The ray tracing is not just for games, and for creators it's going to be very, very exciting, especially for 3D and animation, because what you can do is the real-time ray tracing. You can utilize that with your studio animation, which basically means you can see the final product much faster. Now, enough about the features. What we want to know is what's the actual real-world performance and some of the specs and so on. First of all, let's look at the specs comparison between the RTX 3090 and 4090. Now, the 3090 is on the 8nm process, whereas the 40 series cards are on the 4nm process. We have 56% more CUDA cores on the 4090, 56% more TMUs, 56% Tensor cores and RT cores as well. Now, the memory type is actually exactly the same, GDDR6X, and we have 24 gigabytes of it. Memory bus is exactly the same, but memory bandwidth is slightly increased on the RTX 4090 by 8.7%. The bus interface is exactly the same, PCIe 4.0 x16, and the TDP or GDDP is 450 watts now on the RTX 4090 compared to 350 watts on the 3090. But just wait till you see these results. This is very, very misleading information, I'd say. Now, the MSRP for the 3090 was $14.99, whereas the 4090 MSRP is $15.99. So a 6% increase in the price. But at the same time, right now, you can pick up a 3090 roughly between $1,100 to $1,200, something like that, compared to this 4090, which is about 33% really more expensive. So let's have a look if that 33% in price is actually worth it in performance for creators. Talking about specs, it's very important to mention also the power supply requirement. The RTX 3090 officially by NVIDIA requires a 750 watt plus power supply, whereas the RTX 4090 actually requires 850 watt plus power supply. That's the Founders Edition. Now, the different board partners, like from Asus, Gigabyte, and so on, you check their recommendation because they slightly overclock the card. So this Asus really recommends or suggests you have 1000 watt plus power supply. So my Testbench specs, I'm using the i7-12700 on the Asus B660 Creator D4 motherboard. We have 64 gigabytes on Kingston Fury Beast at 3600 mega transfers per second CL18. The cooler is Deepcool Castle 360EX White in the Fantex P600S case without any of the panels, so it's basically an open case. The SSD is Samsung 980 Pro 1TB. PSU is Asus ROG Thor 1200 watt power supply, and you can see Windows 11 and driver details on the screen. Very important, I want to mention that in some of the benchmarks, my Testbench setup is actually CPU and RAM bottlenecked. You'll see that in probably After Effects and in Premiere Pro even, and DaVinci Resolve, because I just don't have a big platform like a Threadripper or like a very high-end CPU platform with loads of RAM to actually test the CPU. Just to mention that if you had a bit of a better platform, you'd probably see a bit of a increase in the actual GPU scores. So first of all, power draw. We're going to run Furmark for 30 minutes and then see the maximum temperature, the hotspot, as well as the power draw. So the 4090 is drawing 450 watts. No surprise there. That's 28% increase over the 3090. But when looking at the actual GPU temps, which like we have 30-minute temps, is 41.3 degrees. Bear in mind that is over ambient, which is actually 8% less than RTX 3090, and the hotspot is actually 2% lower as well, which is good, which basically means that this RTX 4090, even though having higher TDP pulling more watt, is actually keeping the card very well cooled down with the bigger cooling and everything. It makes sense. Now the benchmarks, and you'll see the benchmarks build up as we go on. First of all, Geekbench 5. This is very generic, just to kind of see where the GPU slots into, very generic calculating benchmarks. CUDA, we are 67% faster on the 4090, OpenCL 56% faster, and in Vulkan 49% faster. Now, the reason I didn't compare this card with the RTX 3090 Ti is because 3090 Ti uses quite a lot more power compared to the 3090. Most likely there's going to be an RTX 4090 Ti coming out later on in the year as well. Then we're going to compare the 4090 Ti and 3090 Ti and so on. But I think to give the RTX 4090 the worst case scenario, we're going to compare this lower TGP card, RTX 3090, and then see how this performs, because this is literally the model upgrade from one generation to the next generation. First of all, some of the photo editing applications like Adobe Photoshop. Now, Photoshop and photo editing isn't massively supported or accelerated on the GPU, so I don't recommend this card for photo editing, because as you can see, we're 4% faster in the overall score and about 5.7% faster in the GPU department or score of the benchmark. If you are wondering about Lightroom Classic performance, then yes, in theory, GPU acceleration is supported in certain things, but really, in reality, you're not gonna see it that much compared to like RTX 3050 to 3090. Let's move on to video editing, Adobe Premiere Pro, and we can see that the extended overall score, we're 8% faster than the RTX 3090, 13% faster in the standard overall score. But if you look at the GPU score, then we're 11% faster, and the effects score, which is 20% faster. So basically, if you're doing a lot of effects and GPU score, GPU effects, then you can expect between 10 to 20% increase compared to the RTX 3090, which is okay, but looking at the price difference, bang for buck, the RTX 3090 still gives you better bang for buck. In terms of Adobe After Effects, we are about 6% faster in the GPU score. Interestingly, the overall score is like within 1%. We are slightly slower, but I think this is within the margin of error. But in the GPU score, we can see we can be about 6% faster. Again, this is another application where we're massively CPU bottlenecked and would see much bigger GPU increase when we'd have much better CPU platform, like with more CPU, power and RAM, then our GPU can sign much more, but I'll have to do with what I have here. Next of all, DaVinci Resolve, and now the news start to become better and better. DaVinci Resolve is very much accelerated with the GPU, and here in the benchmark results we can see that with the extended overall score being 30% faster, standard overall score 34% faster, and GPU effects 41% faster, and Fusion score 45.2% faster. As you can see in DaVinci Resolve, this 4090 is massively better than the RTX 3090, and you can see how the price difference between those two starts to make sense. But let's move on to 3D, and this is where this card absolutely shines. So if you are a 3D creator, now you're gonna have to see these benchmarks here. First of all, we're gonna look at V-Ray performance, and we are almost 2x faster than the RTX 3090 in the CUDA score, and the same in the RTX score. We're pretty much twice as good as the RTX 3090. Now, just to put it in perspective how good that is, if you remember the $19,000 build we did, the Threadripper build with two RTX 3090s running with the NVLink, V-Ray is one of those programs that can actually utilize two of the GPUs running, and we're still 17% faster in the RTX 4090 compared to the two RTX 3090s in the CUDA score. Obviously, in the RTX score, we're about 6.2% slower, but this RTX 4090 is absolutely ridiculous. To be better than two of these RTX 3090s, it's ridiculous performance. Moving on to Blender, in the monster scene, we're 2.2 times faster than the RTX 3090, which is ridiculous. In the junk shop scene, we're 83% faster. In the classroom scene, we're 2.1x faster. That is 115% faster than the RTX 3090. That's just ridiculous performance. And then in Octane Render or Octanebench, we are 91% faster than the RTX 3090. These 3D results are absolutely ridiculous. Like, when did you see a previous generation perform to 2.3 times faster than the previous generation. The big thing here now, which actually, if you look at the NVIDIA's reviewer's guide even, it's not even mentioned there, and I don't see anyone talk about it, and this is where I think people are wrong about it. Because most people look at this card and say, 450 watts, look, we've added extra 100 watts there, we're just getting more powerful, we're using more power to, you know, create these benchmark results. Yeah, 4 times better, but we're also drawing more power. Now the thing is, we've got to look at the performance per watt spec. All right, if this card can do the same task more efficiently and faster, it is actually better. It doesn't matter if it uses more, you know, peak wattage during the peak loads or uses that wattage. What matters is how much performance we're gonna get per watt. So here's what I did. I measured the average wattage in Monster, Octabench and V-Ray benchmarks, and then divided that average wattage with the score to see how much performance we're gonna get per 1 watt. Interestingly, one of the first things I noticed is that even though being 450 watt TDP DGP rated, it's not actually drawing 450 watt like pretty much never in the 3D applications, which just shows that it can boost to that, but in reality it's not actually drawing that. The average wattage on the 4090 was actually lower in every single one of these 3D tests. I tested 3D because that's the most graphics intensive. But then performance per watt in the Monster, in the Blender scene, we are pretty much 3 times as much power per watt than the RTX 3090. Now that's ridiculous test there. In Octabench, we have 2.4 times more performance per watt, and in V-Ray, we have 2.2 times more performance per watt. Now these tests really show how good this RTX 4090 is. If you are a person doing 3D or really graphics intensive things, even running a DaVinci, you can see that the RTX 4090 is not just more efficient, it's more powerful in every single way and form. It completes the task faster while using less power and is just incredibly fast. So my friends, it's not about just the 450 watt TGP. It's about how fast can this card actually complete the task and how little energy it can use. So if you do want to save some cash on your electricity bill, it's worth checking out the RTX 4090. In conclusion, in 3D applications, you can expect 1.9 to 2.3 times the performance over the 3090. In video editing, we can see 10 to 40% increase improvement depending which application you're using. And in photo editing, it's about 5% increase over the 3090. But there are some other applications that can actually utilize this 4090 much more in photo editing. But most of all, the performance per watt is 2 to 3 times better than the RTX 3090. So then, is the RTX 4090 worth it over the 3090, and should creators buy it when we're looking at the price point? If you're a 3D person, and unless you can find an RTX 3090 2 to 3 times cheaper than the RTX 4090, roughly about $500, something like that, $500, $600, then I'd say the 3090 is better bang for your buck. I doubt we're gonna see those prices, maybe in the future. I'd love to see those prices as well, but at the moment the 4090 gives you much more performance. In the video editing department, depending where you are looking at this, remember at the moment when I'm making this video, the 3090 is roughly about 33% cheaper than the RTX 4090, but we can see up to 40+% performance increase in DaVinci Resolve, which makes the RTX 4090 much better bang for your buck if you're just looking at the pure performance. Now in Premiere Pro, it's not so good, the utilization of the GPU, so it's maybe not worth that unless you are doing a lot of exports into H.265 or AV1. Then you can see that the 4090 is actually splitting those exports times in half. So yes, the RTX 4090 is definitely worth it for creators, and I think it's pretty much worth it for the creators mostly, because it's just such a good card. We have large video memory there, super fast large video memory, which is going to be actually very helpful in 3D and video. Honestly, to find some downsides, I'm struggling. I'm seriously struggling to find some downsides. One downside though that I have to mention, I'm not really a big fan of the board partner designs of the graphics cards. I think the Asus TUF one is one of the best ones out there. Pretty much all the other ones look like these cards have been designed for 12-year-olds. I mean, people are paying like $1,500, $1,600 for this card, and we're getting ridiculous designs. I mean, NVIDIA Founders Edition card is probably one of the only ones, and in my opinion, the best design for creators, or just like a minimalistic, a beautiful card design that looks like a premium, mature design. But the other ones are a bit like, what the heck is going on? I don't know. What do you guys think? Let me know in the comment section below which one is your favorite, design of the RTX 40 series graphics cards. But, that's my opinion. And another thing I found in this card here, on this card, there is actually coordinates of the, ASUS headquarters, but they've made a typo on this. So, they're gonna have to reprint a lot of these cards or change the design, because there should be this degree sign next to the 121 instead of minute sign and then second sign, obviously, because if you put exactly this in what's on the card, nothing's gonna come up. I'd love to know what you guys think. Are you impressed with the 4090? I seriously am. I'll meet you in the comment section below. But also, if you're looking to build yourself a creator PC or just best bang for buck PC, then I've got a PC build guides in the description below. There's a 4-part series and budgets all the way from $750 to $5,000. So if you want the best bang for buck PC, pick one of those PCs and you can just configure it and check the upgrades there to configure it to your budget to get the best bang for buck PC for you. Feel free to check it out. All the information is there. Thanks guys for watching, and I'll see you in the comment section below. Bye bye.